Okay, everybody, well, let's get started. My name is John Semmelhack. I am the PHIUS Plus Quality Assurance On-Site Manager. We're going to be having a webinar today on the PHIUS Plus On-Site Quality Assurance Program. I'm joined today with my two other presenters, Ryan Shanahan from Earth Advantage Institute and Skylar Swinford from Hammer in Hand, both in Portland, Oregon. Among other things, Skylar and Ryan are PHIUS Plus PHIUS Raters. So they'll be bringing some insight and experience to you later on today. A little bit of information before we get started on the Passive House Alliance. Most of you probably are already familiar with Alliance, but for those of you who are new to Passive House, new to our webinar program, this is what we do. The Passive House Alliance is trying to inform, connect, advocate, and educate, trying to be at the center of all of these different groups to promote Passive House. We have active chapters throughout the United States: Atlanta, Austin, Washington, D.C. area, Chicago, Denver, Minneapolis, St. Paul, Portland, San Francisco, St. Louis, recently added Vermont, Lansing, Michigan, Dayton, Ohio, with other areas coming on board soon, hopefully. We have a wonderful website at the Passive House Alliance. That's PHAUS.org. Lots of great information there. A lot of great resources to be had. Please check that out. A few things that I want to point out to you that you can find on the website are listings for the national events calendar. So you will see upcoming events, whether they are local events or national level events, such as these webinars. We have the Passive Building University section, where you can get up-to-date information on upcoming trainings for builders, for raters, for consultants. And this is it, the webinar series based on feedback that we've gotten from our members. This is the #1 favorite benefit of members and sponsors. So we do have another upcoming webinar in just a couple of weeks, coming to you from the Minneapolis St. Paul branch. That's on Wednesday, May 15th. So check that out. Please go ahead and mark that on your calendars. In terms of upcoming events, we have a WUFI passive training in Portland, Oregon at the end of June. We have another round of the very successful PHIUS Builders training in Seattle in just about a month. And then, of course, in case you haven't heard, please save the dates, I should say, for the 8th annual North American Passive House Conference in Pittsburgh this year in October 16th through the 19th. We'd like to thank our sponsors of the Passive House Alliance. Without our sponsors, we would not be able to bring you this kind of information, these kinds of webinars. So we'd like to thank our founding sponsor, Certainteed, Platinum level sponsor, Building Science Corporation, Platinum sponsor, Rocky Mountain Institute, Silver level sponsor, Tremco, and green level sponsors, Prosoco, Ultimate Air, Mitsubishi Electric, Chemlink, and the Energy Conservatory. If you're not a member, please check out the member sign-up section and the member benefits on the website, and you can find out information about joining the alliance there. So with that, I will move on to the main part of the presentation here. On PHIUS Plus on-site quality assurance. And I should say I was checking out the attendees list, and it's nice to see quite a few familiar names on there. I wish I could see everybody's faces, but that's the way it goes with webinars. Quickly, before we get into the on-site stuff, the PHIUS Plus on-site program, I just want to remind folks that the pre-certification process is also very important. So I want to touch on a few things about that. For those of you who aren't familiar with the PHIUS Plus certification process, the first part of the certification process is a pre-certification review that gets done by PHIUS staff. So key to that is, key to getting the most out of it is submitting early. So the in-house review is a pre-certification of the energy model and the documentation, drawings, specifications, and so on. There's a back and forth between the project team and the PHIUS certification review team regarding questions and comments on the energy model and the documentation. At the successful end of that process, a project is called pre-certified. So essentially, if you build it the way it is drawn and documented, then you will achieve certification. So one nice thing that PHIUS is now offering is to do what they call a quick review of the energy model and early drawings, even if there is little or no supporting documentation. This can be a great help to project teams to help reassure them that they are on the right track. So we definitely encourage that. And if it's your first Passive House project, please reach out. PHIUS understands that some folks might need a little bit of help in terms of getting everything they need together for the pre-certification process. And remember, the pre-certification is supposed to happen in the design review phase. It's not as helpful to the project and to the process if construction has already started before you submit for pre-certification, or for that matter, construction has finished. A few things, especially to get a handle on early on, air barrier. Really think through the air barrier. Start working on it as early as possible in terms of schematic design. It's all the connections between assemblies that really matter. Of course, simplicity saves time. Simplicity helps get good results in terms of air tightness. Get real about solar access and site shading. There's a technical committee Tech Corner article from December for more information on that. And possibly make sure you determine your site altitude and enter that into your climate data if necessary. And you can check it out. You can check out Ryan Abendroth's blog post from this January. Okay, so on to on-site quality assurance and quality control. Before we start, I guess, getting into the details, I'd like to take a big picture view of these two terms and kind of set out a couple of definitions. So I start with quality control first. And I use the definition that I picked up from a book called The Toyota Way, the Toyota Way Principles. And they kind of define quality control as this. The right process will produce the right results. Or put another way, if you do the right things in the right order, you're going to get the right results. Okay? So I like to step back first and ask myself, well, what are the right results? So for us, we're talking about healthy, comfortable, durable, low energy buildings. Ideally, they're beautiful too, okay? So if we have an idea of what results we're looking for, then we need to think about what things do we need to do? What's the process or processes? What things and in what order do we need to do them to get the right results? Okay, well, to get all of those different things, the healthy, comfortable, durable, low energy, beautiful, we have design processes and we have building processes. So for instance, we do detailed energy modeling. We design our drainage plane for shedding bulk water. We design ventilation systems to help with healthy indoor air quality. We design insulation systems, solar gain and shading, air barriers, drying potential mechanical systems, and so on. And then there's a corresponding component in the real world to actually take the design and get it built. Drainage plane, air barrier, insulation, and so on. And each of these things have to be done in the right steps and done the right way in order to get the right results. So just as an example, zooming in on one particular result that we want to see, we want airtight construction for durability in terms of moisture control, as well as for energy efficiency. So in the passive house world, we define the desired result of an airtight house is less than 0.6 air changes per hour at 50 pascals of pressure difference on the blower door test. And so one technique to get there, for example, is the airtight sheathing method. So I just have a few detailed drawings here from, I believe this is the Dublin project in Urbana, Illinois. And you can see from a design standpoint, we have an air barrier drawing. We're using a green line here, and we're connecting the polyethylene below the slab. We're connecting that to the structural sheathing here. So we have to figure out how we're making that connection, what kind of product we're using to make that connection, and then we need to lay out when in the process that's going to happen. And we need to do the same thing in these other drawings. We need to connect all the seams between all the structural sheathing panels, in this case OSB. We need to figure out how exactly we are going to connect that OSB to the window buck, to the window, and then back to the wall. And then finally, how we're going to connect that wall sheathing to the sheathing that is below the roof truss, in between the roof truss and the service chase. If we do this well, call out how this is going to happen, what connects to what materials we use, and we do this in the right order, and this happens well in the field, we can pretty much guarantee that we're going to hit these numbers. It's pretty much a no-brainer. So that is quality control. If you do the right things in the right order, you're going to get the right result. So quality assurance in my view, is testing the results to make sure that they're right. So for example, in this particular case, that would be a blower door test. So the quality assurance component comes in the blower door test. Okay, so here's the fine print. Oh, wait, here we go. The fine print, quality assurance cannot absolutely guarantee the production of quality products. We're human, we strive for perfection, but we never quite get there. So quality assurance, we're doing the best that we can to test the results and to make sure that we're getting the right results. But we are not perfect. Okay, so moving on, getting into a little bit more detail, why do we, PHIUS, insist on detailed third-party quality assurance? And the general answer is that we, in the US at least, have a general building culture with mostly poor codes, low expectations. We, as a building culture, reward speed over quality and often favor form over function. Our standard level of quality in North America is not particularly good, and it's not really acceptable for PHIUS and for PHIUS Plus certified projects. I don't mean to say that everyone does bad work. There are a lot of people out there doing really, really good work. It's just that we, the quality assurance professionals, such as myself, such as the other raters who are on the presentation today, they find bad work way too often. way too often. And we really want the buildings to perform as well as they are intended to perform. We want the occupants to have comfort, we want low energy, and we want the buildings to be durable. So detailed third-party quality assurance is one way to help really get us there and to assure PHIUS and project teams that we're going to really get the right results. So to that end, I have kind of a few slides. You might call this greenbuildingfail.com if you're into those kinds of fail websites. The next few slides, these are all from, these are not from PHIUS projects, not from passive houses, but these are from various projects that we've seen that were going for various green building certifications. So this is one example from a multifamily building. This is attic insulation. We have huge voids of missing insulation. We have lots of compression where the insulation was not installed very well. And it's pretty much just it's a horrible install. It's one of the worst ones I've ever seen. So this stuff happens not every day, not every week, but I and most other raters kind of have a folder of these kinds of photographs. This particular one, you see this disconnected piece of flex duct and the supply boot down below. This was on a to be certified green building multifamily project. Everyone on the site knew that we would be doing duct leakage testing. The GC knew it. The HVAC superintendent knew it. All of his guys knew it. And we were going to be testing every single unit in the entire building. And yet, this duct was still completely disconnected from the supply boot when we found it. So I don't know what to say more about that. These things happen. This next one was on a single family project. We had a situation with kind of a perfect storm of events. We had poor preliminary site grading during kind of a rough-in period. We had a clogged basement window well drain, and then we had a large rainstorm. And so this is what we got. And you can see the horror show on the inside, that muddy, muddy water coming through the window. The water level was about 4 or 5 inches up on the window. Okay, that's it for greenbuildingfail.com. I don't know if that's actually a real website. Maybe someone can check that out for me. Maybe we'll go ahead and get that domain name registered. A few things in terms of recent actual PHIUS Plus projects. And I will say that often, I guess the most common issues that we're seeing are on mechanical systems. And so that's where I think in general we need, I think everyone needs to pay a bit more attention to mechanical systems on the design end and on the installation end. And certainly on the quality assurance end, we are in tune with it. So one example, we had an installer who was using manual balancing dampers on a ERV that was self-balancing and had a variable speed motor. So this unit did not need balancing dampers, but the installer was using balancing dampers anyway. They cranked down on the dampers to supposedly get the unit to be in balance. And in response, the unit just cranked up the power input to deliver the flow that the controller was asking for. So the result was 133 watts of power input to deliver the flow compared to 45 watts when the rater on the job found out what was going on. So the rater caught this. This was after a while of operation, from what I understand. But that power difference, 24 hours a day, 365 days a year, that's 770 kilowatt hours per year. For a small passive house project, that's 10 to 20% of site energy use. That's a big deal. And another one, the installer, after commissioning on the system, unfortunately, I think this was caught later on, I think by the architect, the installer accidentally reversed the supply and exhaust trunks after removing the flow testing device. So again, we can't catch everything. Sometimes things happen after the quality assurance professionals leave the building. Another example, we had a multi-split heat pump outdoor unit paired with a single indoor unit. We had a ducted heating and cooling system that lacked a filter. We had ERV exhaust registers that did not have adjustable grills for balancing. We had no duct insulation installed on the ERV ducts that are connected to the outside, and we had water dripping from the ducts. We had a lack of condensate drains for the heat pump water heater and also for the ground loop heat exchanger. And then we also had a ground loop controller that was set to run the pump continuously at 28 watts instead of just as needed for defrost and for summer pre-cooling. Okay, that's it for the things for now. For the things that go wrong, Ryan and Skylar will probably share a few other things later on. Most of you know that PHIUS has partnered with the DOE Challenge Home program, and that's pretty exciting. Challenge Home is quite a high performance building certification program or home certification program that uses the Energy Star program as its baseline. So what we have here with the new PHIUS Plus partnership with DOE Challenge Home is essentially a one-stop shop where we have 3 certifications that get awarded with one. So our processes, our program, our quality assurance checks fall in line with the DOE Challenge Home program and the Energy Star program. Most of the quality assurance issues and procedures have already been worked out through the Energy Star program. So most of our raters are already familiar with that process. This is, we hope, will make the on-site quality assurance process go more smoothly. There are some additional checks that are more particular to passive houses, and there are a few things where PHIUS just wants to require a little bit more detail, or for instance, instead of letting a mechanical contractor be the final authority on whether a system is in balance, we do require the rater to do that. We'll get into more of those details in a little bit. In addition, this is really, I think, a great validation for the passive house movement. So the DOE and the Challenge Home program, they really recognize that that passive house methodology and results are really where the market needs to head toward. And so it's really great to know that the lessons learned from PHIUS Plus projects are going to help provide input and direction for the next upgraded versions of Energy Star and Challenge Home. For those of you, you might be familiar with a chart like this from the Department of Energy. This is their energy efficiency goals towards getting to net zero homes by 2020. Net zero new homes is their goal. We're 2013. We're 7 years away. We have a number of builders around the country who are starting to offer net zero homes. So this is really exciting. But starting from a baseline year 2000, we can see that what the DOE recognizes is that we need, first and foremost, energy efficiency. We need huge improvements in energy efficiency in order to get down here, and then a relatively small amount of the difference supplied by on-site power. So where are we going to get this kind of efficiency? Well, for those of you familiar with the code process, we've seen some bumps in the codes in the 2006 code, the 2009, some big jumps recently in the 2011 energy codes for those of you who live in places that have adopted it, or for those of you in California where you're already quite far beyond the 2011 IECC. The next round of IECC 2014 cycle promises to be even bigger requirements in terms of energy efficiency. So where have we seen this before? Oh, passive houses, right. So passive houses back in 1995, 96, proven energy savings over the reference German energy code from 95, which I can assure you was more stringent than our codes from the year 2000. So of course, you can see where I'm going with this. We have passive houses with roughly 70% improvements in energy efficiency. And wait for it, here it comes. That's where we're headed. This is where codes are headed. we'll see if passive house, strictly speaking, becomes code. But I think what we're talking about is passive house levels of efficiency, especially in building enclosures, are coming down the pike in terms of the energy codes. Okay, moving on to the quality assurance process. The the process is combining the Energy Star checklists with the DOE Challenge Home checklists and the single PHIUS Plus checklist into one package. So we have documentation checklists that need to be completed. Much of this is done by the rater, the PHIUS Plus rater. I'll get into who those people are in a little bit. The rater's part of the rater's job is to coordinate getting those checklists put together. We have on-site inspections by the rater, inspections and testing. The number of inspections is going to vary by project, by the complexity of the project, what kinds of installation systems they're using, and so on. It's at a very minimum, at least 2 site visits, but is usually a little bit more. We have, for most projects, we have a ResNet HERS rating, a home energy rating system rating for the homes. And that's part of PHIUS's partnership with ResNet. And then, assuming everything goes well and all the inspections and testing pass, we have a triple certification, PHIUS Plus certification, DOE Challenge Home, and Energy Star. I do say here most projects with the HERS rating, because we do have projects in California as well as Canada. So for those folks out there, there won't be a ResNet HERS rating, of course, but the process is very similar. Okay, we're going to get into a little bit of detail on the checklists. So the Energy Star checklist, there is a, I'll go through them one at a time. So this is what they are. There's Energy Star, there's DOE Challenge Home. DOE Challenge Home references these other checklists. Whoops, let me go back. These checklists here, 5 through 7. And then we have a PHIUS Plus checklist. And you can see that some of these are completed by the rater. There are tasks for the rater to do. There are tasks for the mechanical system designer installer. And there are also tasks for the builder slash project team to complete. So let's go into detail on these. We don't have time to go into super detail on each of these checklists. These are available online. We don't have the full packet up on the PHIUS website at the moment, but that will be remedied very shortly. But let's start with the Energy Star thermal enclosure checklist. This checklist is very straightforward for most passive houses because it's dealing with the thermal enclosure, and this, more than anything else, is what we excel at as passive house practitioners. So we're dealing with insulation levels and air tightness especially, as well as U values and solar heat gain coefficients for windows. A couple of things to note on this Energy Star checklist. There is a requirement that the fenestration package needs to meet or exceed Energy Star requirements. We did ask the DOE Challenge Home and Energy Star teams to grant an exemption for windows that aren't necessarily Energy Star rated. We realize that many of our projects are importing windows from other parts of the world that don't necessarily have Energy Star ratings for them, but they are exceptionally performing windows. So we have an exemption for triple pane windows for that section of the Energy Star and Challenge Home checklist. In terms of solar heat gain coefficient, in climate zones 1 through 4, Challenge Home requires that the fenestration package meets a 0.35 solar heat gain coefficient on average for the whole window. So this is not glazing solar heat gain coefficient. This is whole window solar heat gain coefficient. So this takes into account the blockage of the sun from the frame. So it takes into account a frame factor. This should be not a problem for all the projects that I've seen so far in climate zones 1 through 4. And let me say, we've gone through, I've gone through with others in detail all of these checklists from Energy Star and Challenge Home, looking for possible problem areas and where we found conflicts between typical passive house methodologies and these checklists. We've asked for exemptions, and so far we've been able to get exemptions to all of these issues. If there's something that you see in the checklist that you think is going to be a problem for your project and isn't covered by one of these exemptions, please let me know. Please let the PHIUS team know, and we'll take a look at that in detail, just in case we may have missed something. So one other one that you need to be aware of, Energy Star, and of course, and through that DOE Challenge Home requires a grade 1 insulation install for many building assembly types. However, the ResNet rules for home energy raters, grade 1, for those of you who don't know, grade 1 is the highest, a near perfect or perfect installation of the insulation. So no missing insulation, or little or no missing insulation, little or no compression. The insulation fills the full cavity and fills around any wiring, piping, electrical boxes, and so on that might be in that wall. Unfortunately, or there's an issue for some passive house assemblies where project teams are using an opaque sheathing on two sides of an assembly. So for instance, a Larson truss wall, where you might have OSB or plywood on the inside portion of the Larson truss, and many project teams will use a fiberboard sheathing on the outside of the Larson truss wall. And then the insulation, typically dense pack cellulose or dense pack fiberglass, gets installed blind between those opaque sheathing layers. And ResNet does not allow at this point grade 1 to be awarded by the PHIUS Rater if they cannot see the insulation with their own eyes. So we asked the DOE team and the Energy Star team for an exemption for our super high R value walls. And so what we came up with is as long as the nominal R value for the assembly is at least 50% greater than the Challenge Home reference home design, which is based on the 2012 IECC, then we have an exemption. So for example, if the 2012 IEC calls for a nominal R value of R20, and you're installing an R30 wall in a blind assembly or higher, R30 or higher, then the project would get that exemption. Okay, moving on to the next checklist. This is the biggest deal in the Energy Star world is this HVAC contractor and rater checklist. And this checklist is really, really important. There's a lot of things going on here in terms of the design of the system, from heating and cooling load calculations to ventilation rates, and then the commissioning of the system on the installer side, as well as confirmation from the rater. So a few things to know about this. For those of you familiar with Energy Star and Challenge Home, you know that they use ASHRAE 62.2 ventilation rates, and typical passive house kitchen ventilation rates are not currently compatible with ASHRAE 62.2. So we asked for an exemption to this, and we got that. So for PHIUS Plus projects, for Challenge Home and Energy Star, we have an exemption from doing ASHRAE 62.2 ventilation rates for kitchens. Additional things to know, Energy Star checklist requires for ducted heating and cooling systems, requires total airflow testing for the system. So the total airflow that's moving through the air handler, whether it's a heat pump air handler or furnace or whatnot. PHIUS requires that this must be done by the rater, or at least confirmed by the rater. So we do require a little bit more strictness in terms of that. Ductless systems, so mini split non-ducted systems, are exempt from this. We do also, for PHIUS Plus, PHIUS requires that the rater either does the heating and cooling duct balancing, the individual branch balancing, or at least if someone else is doing the balancing, the rater needs to confirm that the balancing measurements are accurate. We have room pressure balancing, and many of you are familiar with this already in terms of ventilation flows from the PHPP manual, suggesting a limit of 1 Pascal for ventilation flows. So for the PHIUS Plus program, when just the ventilation system is operating, individual rooms with closed doors cannot be pressurized or depressurized by any more than 1 Pascal. For buildings that also have ducted heating and cooling systems, when those systems are running, which is not 24/7, they're running intermittently, we allow the same as what Energy Star and Challenge Home allows, up to a 3 Pascal pressurization or depressurization. And each building must pass both. So in some cases, if the airflows are quite low, a door undercut will suffice. Typically for ventilation flows, that's fine. For larger airflows, such as for larger master bedrooms, for instance, you may need dedicated return ducting or other return air pathways. In terms of ventilation measurements, PHIUS Plus requires that the rater performs more detailed ventilation measurements that are required by Energy Star, and we'll get into more detail on that. Okay, next checklist, Energy Star water management. This is normally completed by the builder. It includes very basic bulk water management steps in terms of installation of the drainage plane, flashings, capillary breaks, drain tile, etc. Much of this is code in many areas and is simply good building practice. It's very straightforward. Okay, number 4, the DOE Challenge Home Rater Checklist. So this first one is a new one that is pretty important to note. So, and this involves hot water distribution systems. And so for those of you familiar with the PHPP energy model or WUFI passive energy model, you know that we have a methodology for estimating the efficiency of domestic hot water distribution systems in the model. And part of the rater's job is to ensure that the domestic hot water distribution system is installed as it is designed. In addition to that, Challenge Home has a performance method for, in part, measuring that efficiency. And so what they have set out is a limit. And they say the limit is a standing water volume of 1/2 gallon in any length of hot water pipe. So between the hot water source and the furthest fixture, you can have no more than 1/2 gallon of standing water. So this is for energy efficiency, as well as for comfort and homeowner expectations to get hot water to the taps quickly. Challenge Home, as well as PHIUS, will be providing some help in terms of calculation tools and best practice examples to help with this. In larger houses, this certainly will be an issue, and we expect that demand-based circulation pumps will be necessary for the longer runs, and this is going to be a good thing for projects. And just I see a few of you are asking questions, and what we'll do, I won't be able to answer the questions immediately right now, but as I switch over to Ryan and to Skylar, I'll take a look at all the questions and we'll answer them as we get towards the end of the session. But please keep going ahead and ask your questions. Okay, so in terms of that standing hot water limit, there's an actual test protocol, which basically what the rater does is they have a bucket that's marked at 1/2 gallon of volume, and they go to the fixture that will hold the most amount of water, usually furthest from the hot water source, and they have a digital thermometer And they open up the hot water tap full and measure the temperature of the water as it comes out right away. And by the time the water hits a 0.6 gallon mark, so actually there's a little bit of, I guess, little slush fund, little fudge factor built into the test procedure. By the time the hot water mark gets to 0.6, the rater must, or the thermostat must measure a minimum of a 10-degree Fahrenheit temperature rise. So that's the procedure for doing the test. Just a quick FYI: standard recirculation systems are not allowed in the system. So, systems that are running on a pump 24 hours a day or on a timer are not allowed. In terms of multifamily buildings, this is something that we will have to discuss in more detail. Obviously, multifamily buildings are a special scenario. Okay, in addition to that domestic hot water test, we have a requirement that all installed appliances are Energy Star qualified. So that would apply to the refrigerator, the dishwasher, clothes washer. We have the lighting requirements. So at least 80% of lighting is either Energy Star fixtures or Energy Star rated bulbs or lamps. This is just a small step up from the 2012 IECC, which requires at least 75% high efficacy lighting. So this should be pretty straightforward. And then in addition to that, all bath exhaust fans, which are individual bath exhaust fans, are fairly rare in passive houses. But if they are installed, they need to be Energy Star rated. And any ceiling fans installed also need to be Energy Star rated. Okay, moving on to number 5, the EPA Indoor Air Plus checklist. Indoor air quality is a big deal. So we need to remember the 3 keys to indoor air quality, especially as we are building such tight buildings. Number 1, first and foremost, source control, then dilution through ventilation, and then lastly, filtration. Passive houses do a great job with ventilation, but we do need to be better with source control. Some project teams do a fabulous job with source control, and others need to improve on this. So source control gets mandated by the Indoor Air Plus checklist. There are some, I would say, fairly low-level requirements to meet in terms of low formaldehyde pressed wood materials. So this would be OSB, plywood, MDF, and things like that. We have certified low VOC or no VOC paints and other interior finishes are required. If carpets are installed, the carpets, pads, and/or adhesives need to be Green Label Plus from the Carpet and Rug Institute, CRI. And if the project is in EPA Radon Zone number 1, you're required to have radon resistant features, which are outlined in the Indoor Air Plus checklist. Okay, number 6 and 7, and this is coming from the Challenge Home program. These are the EPA, what they're calling PV, photovoltaic ready, and solar thermal ready checklists. So these checklists are for projects that are not installing PV or solar thermal, but need to make the buildings basically kind of pre-wired or pre-plumbed so that installing these systems is easier down the road. So this is completed by the project team and or the builder and signed off on the builder. Let me say first and foremost, there are lots of caveats and exemptions to some or all of both of these checklists. So you can see more details on the Challenge Home documentation files. The biggest one is that these 2 checklists are only required for fairly sunny locations. So locations receiving solar radiation of greater than 5 kilowatt hours per meter squared in day. Sorry about that typo. So what you do is you go to this link right here. And by the way, everyone, there's some questions about a previous link that I showed. This presentation is being recorded and it will be available on the Passive House Alliance website not too shortly after we're finished here. So if you don't get this full link down right now, you'll be able to get it later on, and also on the DOE Challenge Home website, as well as on the PHIUS website. So this limit, 5 kilowatt hours per meter squared in day, for those of you who are at home or the office, clicking on this or putting this link in right now, you'll find that this eliminates about half of the country from having to do these checklists. So just about if you're east of the Mississippi and north of climate zone 2, you're probably not going to have to do this checklist. If you're in the Northwest, Oregon, Washington, you're not going to have to do this checklist. Most of this is limited to the Rockies, the Midwest, California, and the more arid states, Arizona, New Mexico, Texas. Okay, so that said, I think especially following, even if you don't have, even if you are below this level and you're not strictly required to follow these PV ready checklist items, building buildings that are PV ready makes a whole lot of sense. It really requires about a couple $100 worth of materials to make it very, very easy for an installer at a later date to install a PV system without a bunch of ugly conduit on the outside of your house, like I did, like I had to do recently on my own house. So please, wherever you are, if you have good access for a PV system down the road, make sure the building is built, designed and built to be PV ready. Okay, then number 8, last one, the PHIUS Plus Rater checklist. We have a little bit more requirements in terms of blower door testing. Many of you are already familiar with that. We do require the rater to conduct multi-point blower door testing using an automated computer-controlled testing software. We take the average of the pressurization and depressurization results together, and we follow the ResNet house setup protocol. And Ryan and or Skylar will get into that in a little bit more detail later on. We do require much more detailed ventilation testing and balancing. We do testing of individual ventilation branches. So not only are we testing whole house ventilation rates, but we are also measuring ventilation distribution. Okay. The rater is looking at the insulation grading. If it is installed to a lower grade, such as grade 2 or grade 3, then that means the project team is going to have to make a small adjustment in their PHPP or WUFI passive model. So either they can, the project team, the builder or installer can fix it and get it up to a grade 1, a near perfect install, or the project team can decide to just go ahead with it as it is and take a little bit of hit on their R value on the energy model. And then in addition to that, many passive houses have some specialized systems that are really not found in other houses. So these would include defrost systems for ERVs and HRVs, perhaps ground loops, perhaps some other systems. So these are additional things that can go wrong, and especially if they're not an everyday item to be installed by a mechanical system contractor, they probably will go wrong or be installed wrong, and we need to make sure that they are set up properly. Okay, I think Skylar and Ryan are going to get into more detail on the blower door testing. Let me get into, let's see, quickly in terms of the ventilation system commissioning process. The rater sets the ERV to the what we call the maximum design airflow value from the PHPP that's provided by the project team. And the rater confirms that the total supply and exhaust are within 10% of one another. Then at that max design total flow, the rater goes to measure the individual branch design values. And if the rater is responsible for it, they will do the balancing on the project. Next step number 4, the rater comes back to the ERV and reduces the airflow rate to the standard airflow value as provided by the project team, and confirms again that the total supply and exhaust are still within 10% of one another, so you have balanced total ventilation. And then the rater measures the actual power input, so the in-field power input at the standard airflow. And then based on that power input, the CPHC, the Certified Passive House Consultant, will update the energy model with the as installed fan efficiency. So we do this ventilation system testing in a few different ways. We have pretty sophisticated and accurate equipment, such as this powered flow hood and this velocity measuring station for inflow measurements. And there are other methods that we may use depending on the situation. We are testing individual branch balancing of the ventilation system. The airflows need to be balanced to within 20% of the design value, or 5 cubic feet per minute, CFM, whichever is greater. Here's an example of room pressure balancing testing. This was on a, I think, extreme situation where a rater on maybe a master bedroom was measuring almost 24 pascals of pressure difference between the room and the hallway. And then after they cut in a pressure relief opening and airflow pathway, return airflow pathway, got that down under 3 pascals. We're measuring power inputs for the ventilation system with power meters such as these. We're making sure the occupants have accessible user controls and accessibility to the ventilation equipment itself for service. All projects are receiving a certain amount of infrared imaging by the rater, which is done ideally both at kind of a pre-drywall, so post-installation, but pre-drywall stage, if the temperature conditions are right for it, as well as at final testing. This is largely to confirm a double or triple check of the insulation layers. Okay, so next question. Who can be the PHIUS Plus rater on a project? So we have a certification and training program for PHIUS Raters. So these are ResNet PHIUS Raters for most of the country, except in California, these are CalCerts PHIUS Raters. California has their own statewide home energy rating system that is different than the rest of the country. And then up in Canada, we also have EnerGuide raters who can also be PHIUS Plus raters. So those are the initial qualifications to come through the training. So we have about 50 raters around the country. You can go to the passivehouse.us website to find a rater. I think on the home page there is a Find a Rater link. So when, for project teams, when you are starting to design a project, actually, as early as you want, make sure you start to get in touch with one or more raters, talk to them about your project, get a quote for their services from them, so you can get that process started. The earlier the better, much like pre-certification. We do have a requirement that the rater must not have a direct financial interest in either the certification itself or the sale of the project. So for example, the rater's fee for doing the rating, the rater's fee cannot hinge on PHIUS Plus certification. In addition to that, the rater cannot be an owner in the project itself. They can't be a contractor on the project, can't be a real estate agent on the project. However, the rater can be part of the same organization as the CPHC or the project team, as long as the rater themselves is not part of the design team. So you cannot have a project where the rater and the CPHC, for instance, are the same person. Okay, raters fees. PHIUS is at this point still laissez-faire, hands-off on rater fees. Those are determined by the raters. We are trying to train as many raters as we can. We are encouraging competition in the marketplace to keep the fees competitive for our project teams. Based on projects that I've worked on, where I've done all of the testing and inspections, I think conservatively for a small, simple house, that it's a roughly 20 hours of work. So use that if you like as a guide for what's an appropriate fee. In terms of timeline for this process with DOE Challenge Home and Energy Star, so right now projects submitted to PHIUS for pre-certification on or after January 1st. So if you submit a project tomorrow for pre-certification, it would need to meet all of the various checklist requirements and actually get Energy Star certification, DOE Challenge Home certification, and PHIUS in order to get the PHIUS Plus certification. There are some exceptions, I should say, to this for multifamily projects. Contact PHIUS for more information on that. Later on this year, in order to make things more straightforward and to be more in line with the Energy Star and Challenge Home programs, we're going to be making this date switch over to a building permit date. So you won't be able to get a project into pre-certification and then sit on it for 7 years and expect to be grandfathered in. You'll have to base it off of the building permit date. So if there are updates to the program, you'll have to follow the updates, although those are always done with a good amount of lead time and advance notice for the phase-in. And then finally, before I move over to Ryan and to Skylar, some ways to keep quality assurance costs down. So this is specifically geared towards project teams. First of all, as much as possible, avoid additional site visits for blower door tests and installation inspections. Do your job right the first time. So I know it's sometimes easier said than done. But yeah, if you, I've had a number of occasions where the designer and builder or installer, often it was a owner builder who was very hands-on. They knew exactly what they needed to do and they did it, and they nailed it the first time. And we were able to run the blower door during a preliminary test and got results down around 0.3 air changes per hour. And instead of doing leak hunting, we just gave high fives. So that's always nice. So that's one way to do it. Number two, especially if your rater is at a considerable distance from your project site, you might opt to do your own preliminary blower door testing. So if you have someone more local who has blower door testing equipment, you might choose to do that. You see that asterisk there. If you do this, make sure you know what you're doing, or whoever you're hiring knows what they're doing and they're using the right equipment in the right way. Check with us if you're unsure. I think we've had at least one case where we had a non-PHIUS Plus rater who did a preliminary blower door test and gave the thumbs up in terms of the air leakage rate, only to find out later on that it was likely that they had the wrong inputs on their equipment, so they were getting inaccurate airflow readings. And so the project team had to do a lot of additional air sealing later on, which was a big surprise for them. Number three, do your own HVAC commissioning, so especially airflow balancing. This is the airflow balancing can be done by the PHIUS Plus rater if the project team wants to, and it's allowed by local codes. It's not required for the rater to do that. So in some cases, the project team might be able to save a little bit of money having a mechanical contractor do their own commissioning work. Having said that, we still require that the PHIUS Plus rater has to still check the airflows afterwards. They don't have to actually do the balancing, but they do have to check the airflows. So those are some ways to keep the quality assurance costs down. Okay, and now I'm going to turn this over to Skylar and Ryan. You have my email address here. Let me leave that up on the screen for just a little bit for those of you who don't have my address already. And while I'm turning it over to Skylar and Ryan, I'm going to go through the questions that people have posted so far, and we'll see We'll try to answer as much of those as we can um, as we go. Okay, Skylar. So, Skylar and Ryan, you are on. I'm going to mute myself for a little while, and you guys can take it away.
Thanks, John. Thanks for the great presentation. I learned some stuff myself, must admit. So thanks for the great presentation. Ryan and I are just going to share some experiences that we've had in the field. Both of us have had the opportunity in this little hotbed of passive houses here in Oregon, Portland, Oregon, Seattle area, to rate a few projects. And we hope that some of our experiences can help you guys on your projects, whether you're a rater, CPHC, or builder.
Thanks, guys. I'm Ryan. I'm from Earth Advantage. I end up rating a bunch of projects that Skylar is the CPHC for. So I've actually learned a lot working from him, and hopefully we can, like he said, share this insight with you all.
We just wanted to touch real quick, just so there's no confusion, that as a PHIUS Plus rater, we're completely independent from PHIUS. Some of us are CPHCs, some are just purely HERS raters that have done a lot of Energy Star work, and now have gotten additional training to do the PHIUS Plus rating. And so, you know, when lots of times we go onto job sites and we get questions about the PHPP and about PHIUS and when they're going to get feedback and things like that, and just want to be clear that we aren't really in the PHIUS loop, so most of the communications coming directly from the builder, the architect, and the CPHC, primarily the CPHC, and so just we need to be informed of changes to the plans and the process as they're made, and you can't just assume that if PHIUS knows about something that we've been informed as well.
That's a really good point. I find a lot of times builders and project teams are asking me as the rater how they should input something into their PHPP or various questions about the modeling that I could potentially answer as a CPHC, but I realized that a lot of those questions would have been answered had they submitted their project for pre-certification, like John mentioned earlier. So it cannot be overstated how valuable it is to get that information into PHIUS early so that they can answer some of those questions for you. And so our job is literally just to verify that you've built what you designed on the plans and in the modeling is the same as what we see in the field.
And as John mentioned, the initial kind of idea was that there would be 4 site inspections, and now with some experience, we found that with photo documentation or even video documentation that we can get away with as little as 2 site visits, and then there's 2 other optional ones. And so the key, regardless of if you're doing all 4 inspections or not, I think is to have a really good photo documentation process for your project. And so it's really important someone on the project team is assigned to taking photos and that you have a catalog and an organization system, because they've come in handy on it, I'm sure, for PHIUS and for us. And so you know, I just really recommend that there's a standard protocol for the project team to be taking lots of photos.
And I'll add to that that Skylar and I tend to prefer to do all 4 site visits. There's a lot to be learned. There's a lot to be caught in the inspection process that might not be captured in photos. I would suggest always sticking with the 4 site visits, assuming that it's, you know, within a decent proximity to wherever you're operating out of.
And so how we kind of start the process is before we do anything on site, we like to familiarize ourselves with the the PHPP and we go through the data and look at the inputs and take notes and compare that to our Rater checklist to see what inputs we should be looking for when we're on site. John's developed a great spreadsheet that you'll see us toting along with us when we're on site, and we'll be filling that out after our visits. And then after that, we'd really like to have like a team meeting, ideally before the process gets started, whether that's on Skype or whether that's in person, but just with the contractor, the architect, the CPHC, just going over the process so there's no surprises.
Even subcontractors could be really important so that they know who they're sort of answering to, who's doing those inspections. There's a lot of value that you can get out of bringing everyone to the table early.
And I'll just run through these 4 inspections just real quick, even though John already did. But essentially, there's the first inspection, which is the slab. Oops. And we'll basically, if we need to make multiple trips, if there's some initial footing pours or something like that, typically if it's an isolated area where you're going to have a footing or something out of the ordinary, that can typically be photo documented without a separate trip, even if you're going to do a site inspection for the general. But basically we'll be looking on this lab inspection that the foam is within tolerance and that the foam itself matches the manufacturer that was submitted as far as the data sheet to PHIUS during the pre-certification process. You know, we've seen EPS swapped out with XPS or and other insulation materials, and so we just need to be sure that the contractor, if they substitute something, that it gets updated in the PHPP model.
We've even caught things like footings that are not in the plans or are not insulated the way they were on PHPP.
Yeah, John had an example in a presentation where some stairs were basically, there was a footing poured in and the stairs were built into a basement, and that whole footing for those stairs was uninsulated, and so it had to be retrofitted to prevent any problems, and also had to be updated in the model. So just things like that. We're just verifying that what's in PHPP is what is done on site.
Another important one is where we're looking at the vapor barrier quality. That can be a difficult one to do well on site. It is pretty easy to draw nicely into a set of plans, but on site you realize it's a different experience. And that's a really good, long-term durability thing, is to make sure that there's a good airtight vapor barrier set up there.
Hey guys, this is John.
This isn't.
One thing I'd like to just interject quickly for Skylar and Ryan, for the rest of the audience. Skylar and Ryan are, excuse me, quite special PHIUS Plus raters in that they are also CPHCs. So they are also certified passive house consultants. So they are quite familiar with the PHPP. Not all of the PHIUS Plus raters are also CPHCs. So we probably have maybe 20 to 25% of them are, but most of them are not. So not all of them will be have the training and familiarity with the PHPP or WUFI passive modeling tools to go in and do that. So in those cases, they're really mostly just they're looking at the drawings and specs and checking to make sure that the drawings and specs match up with what's installed.
That's a really good point. I mean, I've been handed some, the PHPP and the plans and expected to go find the information in the PHPP that I need as the rater on a few projects, but I can see how if you didn't have the training under your belt, you would not want to be searching through PHPP for the right information. So it'd be really important for those raters to make sure you're giving them the right data out of PHPP that they have to go looking for.
And all of that information should be readily available in the plans and incorporated into the design as part of the pre-certification, because PHIUS is really a stickler on that info to make sure, basically, if it's not on the plans, how are they supposed to know if things were detailed properly, and how is the contractor supposed to know how to do it right? So in general, if you make changes or You know, if you just say you're going to work your air barrier details out on site, most likely you're not pre-certified yet. And so that comes down to needing to get pre-certified, because PHIUS is going to make you detail out all of those junctions and all those critical aspects of your design. And I just wanted to talk real quick about shading, how critical this is. I've gone to do slab inspections on a couple of projects now, my first two PHIUS Plus projects, and neither had completely finished the pre-certification process yet, and they were scrambling to get accurate solar data for the site for their shading page, and that had a big impact, and they actually had to make some tweaks to their building because of the actual results that we got. So the key is to get pre-certified, make sure you've already done your shading analysis. Like, that should be one of the first things you do, because it can have a really big impact on the performance of the project. Here's just some photos on site, kind of what we expect to see when we inspect the vapor barrier. Typically, if we've done like a slab inspection already, then just really detailed photos of this cataloged and sent to us can substitute another site inspection if the project's a little a ways away from the radar. And then, you know, one thing that often forgets, something that the project team forgets sometimes, or the contractor, is insulating all the pipes in the slab. And so you have to take really detailed photos of all your hot water lines and anything else that needs insulated that's in the slab, and verify that if it's not left exposed for an inspection. So be sure that all of that work is getting done. After the preliminary site inspection, it's really quite a while until we go on site again. And then the second test is typically the preliminary blower door test, where we're inspecting the air barrier connections at the windows and doors, and the roof to wall assembly, and the foundation to wall assembly junctures, all those critical junctures. And we're also looking to make sure that there's no thermal bridging that was added from like any patios or anything like that that might be new on the site, just kind of keeping our eyes open for that. And then we're doing the preliminary blower door test, and some of us like to bring theatrical fog with us on that preliminary test. Most projects I've gone to are in the 0.3 range on the first try anyways, and so the theatrical fog is really just optional if they have the budget for it and want to spend extra time chasing leaks. And I find it's a really good educational tool for the carpenters on site, especially if they haven't been on a passive house before. They can kind of see where they do leak and do better next time. And
I was going to add another sort of poor man's trick would be if you could show up with a flashlight at nighttime and look for light. Light is also a telltale sign, just like the theatrical fog. So one thing that we both wanted to emphasize here about preliminary blower door testing is that you really always want to run the blower door in both directions, meaning you're pressurizing the house and depressurizing the house. I've rarely seen scores that come in the same, and so what we're finding is that a lot of building assemblies and components function differently under pressurization versus depressurization. If you're only doing the depressurization test, this pressurization test could bite you at the end of the project. Bite you where it hurts, I guess, is a good way to say it safely.
yeah, and there doesn't seem to be a rhyme or reason to it. Like, I had this theory that the tilt and turn windows that are in swinging would do better under the pressurization test, and that seemed to be the trend for a while. And now I'm finding that trend isn't continuing, and so you know, it really kind of depends on your air barrier strategy and maybe potentially dampers and things like that elsewhere.
I've actually returned to the same site a few weeks after I ran a preliminary blower door, and we ran another one just to confirm that we were where we were at after some additional penetrations had been made and sealed, and we found new leakage from taped seams that had started to peel. In this case, it was the project team had run out of a better quality tape and had substituted a cheaper tape that needed to be heat activated to work right. But my point here is just that if you can afford it and you have the time, as much preliminary blower door testing as possible is really worth it, because you can find out a lot of information and make improvements that'll last, for the life.
And it's just really, I want to reiterate too that it makes a lot of sense to do additional blower door testing, because it's really valuable information for the project team. And when you're designing your assemblies, you might find ways you can do it better next time, possibly more efficiently and less expensive, or maybe find a way that maybe you need to invest a little more in the way you're flashing your windows or something like that to get a better air tightness connection that goes more smoothly and is more consistent.
So this is the first official required visit, the pre-drywall inspection. Any raters who work with Energy Star homes or LEED homes or other home certification programs have experience with this. This is when you're going in to verify that the insulation is installed well, and it's the one last time you get to see it before it gets covered up. So sequencing is really important here. When you have detailed wall systems that might have several pockets of insulation, it's important to work with the project team on when those things are happening so that you can go in and see them when they're available to see. Once things get covered up, you spend a lot more time trying to see it through IR cameras when you could have seen it more easily earlier on in the process.
And this is another time when, on hammer and hand projects, for example, we always do another blower door test after the insulation, and we run the IR camera, especially if you have something that's like a Larson truss. It's really nice to have the IR camera. Tadashi, who is going to be presenting with us today, he sent some good photos that we didn't have time to insert into our presentation, but he basically showed some of the blind Larson truss type assemblies, which are one of the riskier types of assemblies from an insulation perspective, because you can't visually verify. Like if you're dense packing your Larson truss from the outside to the exterior fiberboard or gypsum board, you're just going by feel for the most part, and if something got hung up or you missed something, it's difficult to verify without IR. And so the blower door can help show some air leaks with an IR, and then also just the IR, if there's a temperature differential, we'll be able to see where there were any install errors, which when you have thousands of square feet of wall area, there's always going to be some areas that are deficient, so it's really important that they get repaired. Another very important thing to think about, and this isn't necessarily the pre-drywall inspection, this could be also during the air barrier inspection. One of the things we look for, we look at the domestic hot water lines, making sure that they match the plans and that the pipes are insulated to the same spec that they're showing that you're showing in PHPP. And then also the HRV ventilation ducts. Oftentimes the insulation thickness in PHPP doesn't match the on-site conditions. Lots of times I've seen the PHPP with like 4 to 6 inches of insulation around the pipe, which, if you have a 6 or 8 inch pipe, that makes the pipe, if you have 6 inch insulation around the pipe, that adds another foot diameter to the pipe, and so typically that's not happening. And I've seen this, the gray duct that you're seeing on the left on the screen is the Zender duct that it's like the Comfo pipe or the Comfo tube, one of those two, and it's only about 1 inch thick, and I've seen that entered into PHUP as a couple of inches. And so just be sure that if you have a higher R value spec for that it needs to get wrapped with insulation. Sometimes the contractors, even the HVAC contractors, don't realize that those exhaust air pipes and fresh air intake pipes coming from the outside are essentially the same exact temperature as outdoor air. And so, high risk for condensation problems if they're not done properly.
I've seen it's pretty common too that the HVAC runs will get installed a little differently than they are on the plans. So it's pretty important to make sure that if there's significant changes, that the PHPP is getting updated to reflect that, because a rater will certainly be looking for those things. And tight spaces are one of the reasons why you see so many differences.
And this is John again. So this is kind of where I come into things on the tail end. Is I'm collecting the raters reports from the site visits, in terms of what they're seeing out on site, and matching that up to the PHPP. This is before final certification. So in some cases, either PHIUS will just make an adjustment to the energy model kind of in-house if it's something small, or if there are large changes that need to happen, we'll ask the project team to actually go in and make those changes. To date, we haven't had any situations where there was something so big that it knocked anybody out of certification. But at the same time, I would be surprised if it didn't happen at some point.
Thanks, John. John already showed these slides, but the big now we're on to the very last inspection, which is the final site verification, and one of the big components of that is commissioning the ventilation system flows and also the HVAC flows. And so typically what you're going to see, I think a lot of people are moving towards using the flow blaster on the right, and that allows us to really accurately measure the ventilation flows and the HVAC flows up to a certain level. We might have to use a different flow hood for higher flows. I'm in a really big house that might have a more conventional HVAC system. But there will also be, so the first thing we do is we verify the actual flow before it goes out to any of the supplies and exhaust ports, and just ensuring that it matches PHP, and that's with the FXP 10 unit, or it depends on the duct size. If you're using a 6-inch duct, we'll be using the 6, 7-inch the 7, and that nifty little tubes allows us to hook up a manometer, and we'll be drilling a hole in the duct and sliding that in there, and then we'll be patching it when we're done, but it allows us to get really accurate flow measurements.
This is one thing I've noticed takes a lot longer than you assume it will take, so I would budget a considerable amount of time for this testing in particular.
Yeah, and so, you know, generally the idea is supposed to be that we're just verifying the flows and we're not fine-tuning the system and commissioning it. And so it goes much more quickly if the HVAC contractor has already commissioned the system and it's good to go, and we're just kind of verifying everything. Sometimes that's not the case, and we spend time commissioning the system, and so that's going to be an increased cost that hasn't been factored in yet, so keep that in mind.
Another thing to look at is that top end of the flow blaster that you're looking at the right. That sits flush against a flat surface, and so if your register grill is mounted right up against a wall or a flat ceiling, or a vaulted ceiling for that matter, it's pretty easy to get that to mount up nice to it. But something a rater would appreciate knowing going into your final inspection is where those registers are going to be and how they're mounted with respect to flat surfaces to mount the flow blaster to. I've had to sort of engineer some scenarios to get them to perform the way I wanted to in order to accurately test them, which of course added to time in the field. So keeping your rater up to speed on what the finished product is going to look like could be advantageous.
And that can be discussed during, you know, rough-in during one of the earlier inspections, so we're all on the same page and we come prepared with the right materials and everything to do the test. And so that's the flow blaster, just showing that we're going to be going to each room and verifying the flows and that they're matching what's in PHPP.
But if you take a look at that register there on the left, an example I had that was hard to measure was when they had exposed round metal pipe with these guys popping out of each side. So that's just an example of where if it isn't mounted flush up against a surface of drywall, for example, it could be difficult.
John already showed this, but we'll also be going through the building and ensuring that there's proper return air pathways. Typically, we're supplying fresh air to the bedrooms, and we need to be sure that that's pressure is getting released and moving into the main space. With the very low flows that we have in Passive House, that generally isn't a problem unless there's really high carpet that's really constricting the airflow at the bottom of the door. And like John said, it's really critical that you're realistic in PHPP about your pumps and your fan energy and things like that, because we're going to be measuring them and verifying that what's in PHPP is actually accurate, and that if there's additional pumps and systems that aren't in PHPP, we're going to note them and measure them, and they're going to have to get added. So if you're really close on primary energy, for example, that could be a big problem. So just be realistic about it early on, and really try to think of what kind of pumps you're going to have in the project. That way it can all be accounted for in the PHPP and there aren't any problems down the road. And then kind of the big finale and our favorite part is running the final blower door test. And unlike the preliminary test where we're typically just doing a single point test, depressurization, and a single point pressurization, we're doing an automated TechTite blower door test. If you're using Minneapolis, there's the TechTite software. If you're using a different brand like a RetroTech, it also has a software. And we're gonna this test probably takes what 20 minutes or so to perform, 20 to 30 minutes, and basically the software will control the fan and it'll ramp it up and average out a bunch of different pressures and give us a more accurate blower door reading. And so it's pretty cool to watch the test go down, and you can see how your building air leakage increases as the pressure goes up. And then in the end, it shoots out a report that will provide the project team after the test that has really detailed information about the air leakage characteristics of the house on pressurization and depressurization. And hopefully, if everyone did their job right, like John said, we're not chasing leaks at this point. We're just giving each other high fives, and really the house is certified and good to go at this point. If PHIUS has everything and the project's been pre-certified, this is really it.
One thing that I think is really worth noting here is that these blower door frames and systems really weren't built for passive house levels of tightness. And so one of the things you see that it's very telling in the picture on the left is a blower door frame covered in Sega tape. We're really making up for the inconsistencies in the frame itself, so that the house score really isn't paying the penalty that frame brings to it. So I've noticed on every single job that I've done that it's really important to bring tape out, not necessarily Sega tape. The builder in this case had extra Sega tape to use, but that you want to bring tape out and feel for the air leaks just at the door frame itself. That might make or break that crucial 0.6 number. So you want to bring tape and make sure you're getting to everything you can, so that the inconsistencies in the blower door setup aren't affecting the house's rating.
Yeah, I mean, it's not uncommon to test a passive house that's in the 40, 50, 60, 70 cubic feet per minute leakage range, and so that can easily be transmitted around the frame of the door, between the blower door and the actual door itself, and where the fan is going through the door. And so we really like to give our team the best score they can get, and we take the time to tape up the frame typically, and really get a more accurate number. And I've seen the rating go from like an 80 CFM to 70 CFM just by taping around the door, so it's not inconsequential. And then we also really recommend, this is more for the raters out there, that you bring an additional crossbar for the blower door frame. I would just recommend buying an extra one. That way the frame sits more securely in the door, and it'll bring tape and bungees and cardboard for all the testing and anything the contractor. It's nice having the contractors on site because they're always really handy, and they are able to help craft up some of these things that are needed for doing specialized testing of the HRV. And also, to make the test go faster, one thing we want to make clear is that If the HRV ports, for example, are in a really tough situation or like tough access situation, whether they're on a roof or in a high sidewall, that the builder is going to have to ahead of time seal those up from the from the outside. And to be clear, we don't seal the outside of the duct to the building. We seal just the inside of the duct, and so we really just want to measure the air that would be going through the outlet port. And so we want to be careful that if the actual duct itself is leaking, that we're not sealing that off, because that would skew the results of the test. And so just be sure that the team is aware that we'll be taping off things like HRVs and plumbing vents, and intentional holes in the envelope. For the most part, we'll be sealing for the test. And if they're done beforehand, then it'll just make it go faster and it'll save you money.
One thing I've seen done on a site was the project team had the HVAC contractor come back and seal the HVAC system themselves, so that it wasn't left to our how good of a job we could do taping it off. They actually sealed it off with metal and mastic, and it was really nice to see that they could do that for us. So keep in mind that significant leakage can come through the HRV during this test if it isn't taped off or sealed off correctly.
Cool, and that really wraps it up for us. We don't have much more to share. I think we'll hand it over to John, and he can kind of start the QA process if anyone has any questions. I really appreciate you all listening in, and I hope you're all getting sunny weather like we are in Portland.
Thanks, guys.
Okay, so this is John again. Let me put you guys on mute. And I'm going to go ahead and take control of the screen again. And I've been looking through the questions, so let me go through these and get to a couple of them that I wanted to share with the full audience. Let's see. So James Hartford was asking to get the link for the information about getting real about solar. So that is here. So it's a bit of a long link. Please, if you don't, I guess you could, for those of you who can do this, maybe take a screen capture right now while I have this up. Let me get my mouse out of the way. But feel free to email me and I can get you that link directly. It is also in the full listing of Tech Corner articles on the passivehouse.us website. Mark Miller was asking, what are the plans for on-site quality assurance for passive houses on larger scale commercial buildings, so not residential buildings? So we're taking those kind of on a case-by-case basis. We don't have too many of those in the pipeline right now, but we do realize, especially on very large buildings, some of those projects may already have commissioning agents, the third-party commissioning agents that the project team works with. So we will have to take those on a case-by-case basis to figure out what appropriate quality assurance methods are going to be for those larger buildings. But in general, the process is largely going to be the same. There might be some amount of different personnel doing the work, but we'll be checking insulation, air tightness layers, doing blower door testing, ventilation, detailed ventilation commissioning will be required, detailed balancing on heating and cooling airflows if there's ducted systems and so on. So the process definitely does scale up. Just dealing a bit with different equipment capacities as we get into bigger buildings, slightly different testing methods, and perhaps different people actually doing the testing. Let's see. Kevin asked, I've heard that HRVs are not, so heat recovery ventilators are not allowed in projects. Is this true? And if so, why? So no, this is not true. HRVs and ERVs are allowed. It's up to the project team to decide which they would prefer. That choice depends a lot on climate location. and on what the particular projected occupant usage of the space is going to be. So again, no, HRVs and ERVs are both allowed. And to that end, technically, an HRV or ERV is not even required. It's just that most projects choose to use HRVs or ERVs in order to meet their annual heat demand limits and annual cooling demand limits. In most climate zones, it would be very hard to meet those limits with a supply ventilation system or an exhaust ventilation system. Okay, Donald Puffer was asking us to address what volumes in the building are tested. So specifically, I believe for blower door testing, I would imagine. So the differences between gross volume, net volume, or what we call net interior volume. I'm sorry, excuse me. So for blower door testing for PHIUS Plus projects, we use what is called, at this point, what we're using is what's called the net interior volume. And so this is using inside dimensions of the building. So essentially drywall to drywall, finished floor to bottom of the ceiling. So we're not counting interior walls. We're not counting columns, for instance. But we are counting open areas of stairways, for instance. Conceptually, the best way I've heard this described is to imagine a two-story building, and you cut a small hole in the ceiling of that second story, and you start pouring in marbles, and you've got all your doors open, all your closet doors open. Those marbles would start to fill up the entire volume that is inside the building, but would not fill up, for instance, interior walls, for example. So that's the all the marbles description that I like to use for net interior volume. So that volume is the volume that is used for doing the air changes per hour for the blower door test. So the ACH 50 calculation. If you want a very quick shorthand on what your airflow rate, your CFM at 50 Pascal airflow rate needs to be at a given volume, you can just take the volume and divide by 100. So if your net interior volume is 20,000 cubic feet, your CFM 50 on the blower door test would have to be at 200 CFM 50 or lower in order to hit the 0.6 air changes per hour at 50 pascals. Okay, Michael Grant was asking us to exactly go over exactly what gets sealed and what gets left open during blower door testing. So we follow the ResNet protocols since we are using ResNet Raters, and we follow the same protocols as Energy Star and the DOE Challenge Home program. And this actually falls very much in line with the European standard method B. I forget the exact number. But essentially, what gets sealed is any openings for continuously operating ventilation systems. Um, so you would turn off the ERV and you would seal off either at the exterior hoods or somewhere on the interior, or you could do both. You would seal off those openings, and then nothing else gets sealed in the entire building. So if you have for instance, if you have a wood stove, you can close the damper to the wood stove, but you're not allowed to tape off the flue. You're not allowed to tape off the firebox door. If you have let's say a kitchen exhaust hood, a kitchen range hood that is vented to the outside, you are not allowed to tape off that hood. So that's it in a nutshell. If you have more questions on that, we'd be happy to answer. But in general, basically nothing gets sealed except for the holes that are the ducts for the ventilation system. Wayne is asking how much average time does it take to perform both blower door tests? A blower door test is pretty straightforward to set up. A typical, even if you're running a computer controlled test, that can be set up and run in about a half an hour. So that's how much time the blower door testing uh, takes. So there's usually more time in the setup than there is in the actual test. Let me just go back through here and see if I can see if there are any other ones that I need to answer. Okay, Steve Eagleberger, who's one of our raters in Denver, he was checking in about the Energy Star rating requirements. I think, Steve, I'm guessing this is for maybe appliances or light bulbs. Could it be Energy Star or better? So yes, Energy Star or higher rating will be fine. For things, sometimes we might get into a situation where a client wants to import a specialty European appliance, I imagine we could make an exception for a non-Energy Star rating on something like that, as long as it was deemed to be a very energy efficient unit. And let me just double check that we've answered all the other questions. Okay, great. Yeah, I think I've gone through all of those, and we're running towards the end of our time allotment here. We'd be happy to answer any more questions. Mark Miller, who's the director of the Passive House Alliance, suggested that on the Alliance web forum um, that is open to Passive House Alliance members, that we could set up a PHIUS Plus on-site rating and rater forum section uh, to take and answer questions there, and I think that's a great idea. And I'll also be able to kind of compile the more common questions there into an FAQ as part of the certification process packet. So I think that's it for tonight. So thank you all for attending, it's good to see so many familiar names again, and hopefully I'll see you all in person after not too long. Maybe most of you at the Pittsburgh conference in October. All right, thanks. Have a great evening, everyone.